This is Dr. K. Rajendra Prasad. I am working as professor and head for the departments of cybersecurity and data science. Today our discussion is ambiguous grammar. Because of in the context-free grammar, we have to see what is the importance of context-free grammar. So context-free grammar, from that we have to try to generating the context-free language. This language is useful for determining the corresponding accepted strings or valid strings. So here we have the very important phase in the compiler design is lexical analysis. In the lexical analysis, so we have to go into discuss what is the parsing mechanism, and how can valid tokens, and how can you generate some sequence of valid tokens. So that case, I think we got already idea in last classes. So today class we have to go into discuss about syntax analysis phase. One of the important concept is grammar and also ambiguous grammar. Already we have the grammar, nothing but it can be generated I think with the help of totally for 4 different tuples. One is called as V and D and P and S. So it means set of variables and set of terminals and set of productions and starting symbol. So from that we have to getting the idea is called as grammar. But in the grammar we have taken one biggest problem is ambiguous. Because of we want to define any well-known grammar, nothing but it must satisfy some kind of properties. It should be ambiguous grammar. So what is the ambiguous grammar? So what is the unambiguous grammar? Let us answer with a clarification. If it is an ambiguous grammar, means we have to generating a valid tokens in many ways. So means here instead of taking various alternative ways, we try to generating the valid tokens or syntax of the productions, and finally with the help of only for one single distinct idea that comes so with the help of unambiguous grammar only. So here what is the basically ambiguous grammar is? So ambiguous grammar is said to be ambiguous because of we have more than one leftmost derivations or more than one rightmost derivations for deriving the one particular string. In that case the grammar becomes ambiguous grammar. So here I am defining the same idea is there exist more than one leftmost derivations or more than one rightmost derivations. And also we can say that from those derivations we try to generating more than one different positives for the same input string. So here a grammar becomes ambiguous grammar when nothing but we try to determine one complete valid string with the help of more than one leftmost derivations or more than one rightmost derivations or the corresponding more than one different or distinct positives. So for the same input string, that case the grammar is said to be ambiguous grammar. Means here the thing is we have defined some input string. Suppose the input string is A plus A. Means we have to getting this kind of input string with the help of more than one leftmost derivations, different leftmost derivations, or more than one different rightmost derivations, or more than one different positives. So then the grammar is said to be ambiguous grammar. Right? We have see in coming slides. So what are the examples and how can you understand the grammar becomes ambiguous grammar? The second point is when it becomes not ambiguous, it's also called as unambiguous. Means you should restrict. It is possible to derive exactly for one leftmost derivations only. Not possible by taking more than one leftmost derivations for the same input string. Then that is called as unambiguous. In a similar way, we can defining exactly not more than one rightmost derivations. Strictly, we should restrict using only for one possibility of deriving the rightmost derivations. Then you could generate one input string. Then that becomes unambiguous grammar. In a similar way, come to the positives point of view. So you want to show only for generation of one single positives only. not for more than one different parties. For the same input string, then the grammar is called as unambiguous grammar. So we have concluded that what is the good? Whether the grammar becomes the ambiguous grammar or the grammar becomes the unambiguous. So try to removing the unambiguity and try to remove the ambiguity property. So means if the grammar has becomes the ambiguity, then you feel as it is not good. It is not good for the compiler construction because of so we try to generating more than one leftmost derivations. For that, honestly, you have to spending more than one different transitions paths from starting to your expected destination. So that case, honestly, we have to getting more number of stages and more number of different paths generations from source to destinations. That's why at that time, honestly, we have to increase the complexity for the construction of finite automata for the corresponding compiler construction. Because of compiler construction, at that time, you make use of what the main idea nothing but with the help of the finite automata. So with the help of the finite automata, you are going to compiler constructions. In the finite automata, you should remember that is constructed using some set of states. Like this is a set of states. So for example, this is a finite automata. This is a set of state. And if you have to go for different paths, okay. So means is one of the path one is go for another path two. Means honestly you have to increase the complexity by defining more than one different paths for representing the same kind of input string. Here also the input string is AB. Here also the input string is AB. So for this case, you are getting the input string is AB. Here also you are getting the input string is AB. So for generation of same input string, unless you are going to take more than one different paths. So at that time, so unless you have to spending more number of transitions and more number of possible states. So with that, what the basic problem is but complexity. So complexity of finite automata is increased. So that complexity of compiler construction also you have to getting it. So it becomes increased. That's why we should be very careful about our grammar. You are taking any one of the grammar, that should be unambiguous grammar only. Suppose you are taking the grammar is ambiguous grammar, then what happens nothing but unless we have to increase the complexity of the compiler construction. That's why the last point is we should remember if the grammar has ambiguity, then it is not good for compiler construction. We should remember these are the ideas regarding to the ambiguous grammar. So here we are going to verify what the example of ambiguous grammar is. This is one of the example for ambiguous grammar. So here I am taking the 1 to the 24 set of productions. First I am trying to what the grammar for this is. So grammar I think we have the idea is 24 with 4 tuples VTPS. The 4 tuples are variables, terminals and productions and sets. Here what the variables nothing but. So first of all I come to again the clarification of variables and terminals. So variable is also called as non-terminal. It's also called as non-terminal. So what do you mean of non-terminal and what is the terminal is? Once again I revise the ideas of non-terminal and terminal for any particular symbol. Means you are taking the any symbol, so that symbol able to define any derivation. So means that case the symbol is becomes non-terminal. So for the same symbol, I think no derivation. You are trying to define no derivation, then that case the symbol becomes a terminal. So let us come to for two clarifications: what the terminal and what the non-terminal. So means any symbol, so it has a derivation in the grammar, then the symbol is called as non-terminal. Any symbol, so for that symbol, itself it is terminated. Itself is terminated. There is no specific derivation. Then that becomes a terminal only. So let us come to the idea of so what is the terminal and the non-terminal with the help of this example. So we have checked out this example. So what the example is here? I am taking the example is one production is P1 production is it becomes E implies E plus E, and P2 it becomes another production is E derives what is E with E, and P3 is it derives the E implies ID. So means this question given the in the form of a slash alternative slash nothing but is the production 1, is the production 2, is the third production. So here this case we have seen totally for how many different productions sir? 3 different productions sir. So after defined 3 productions sir, and as per the definitions of terminals and non-terminals, so what I said is non-terminal but that particular symbol has the derivation. So which are the have the derivation is capital E. If capital E has derivations, okay, so it has some derivations, has derivations. What derivations are E derives sometimes is E plus E, sometimes it derives the E into E, sometimes it derives the ID. So now what is called as E is a concluded as a variable, is as a variable because of it has a derivation. And from that, so which are not having the derivations, symbols are placed, the symbols are placed, the place symbols and the asterisk symbol and some other ID symbol. Okay, so these are not having the derivations. So nothing but these are called as terminals. These are called as terminals. So means after defining the some tuples in the grammar, let us come to conclude. The question is so whether the following grammar is ambiguous or not. Now I am concluding totally for what are the variables, what are the terminals, what are the productions, and what are the starting symbol is. Here G is nothing but I am saying is what are the variables sir? Capital E is a variable only for one single variable, and terminals. Terminals are I am defining many terminals here in this grammar. The terminals are place asterisk and ID. These are the terminals. And what are the productions sir? Already I shown the total for 3 productions as per number I given. These are the 3 productions. Okay, you are taking P1, P2 and P3. I am not writing here. Already I had explained about these productions. And what is the I think where is starting from? The starting symbol is there should be yes only. So this is the grammar. Now you are defining. So what are the input string is given in this question is, and based upon that, and we can show that whether this grammar is ambiguous grammar or not. So here I am taking the input string is ID plus ID. So now I'm trying to showing at any case more than one leftmost derivations or more than one rightmost derivations or more than one different positives. That case the grammar becomes ambiguous grammar only. So now I'm showing that what this thing is ID plus ID into ID. For the obtaining the same string, I want to show some different derivations. Okay, then only I'm going to prove this grammar becomes ambiguous grammar. Now let us we have to see that the case is E becomes, suppose I started with E plus E. I am trying here leftmost derivation. Leftmost derivation means for every case you make a substitution is means you want to replace what is the symbol at every step nothing but leftmost non-terminal only. Here what is the leftmost I am putting here underline. This becomes the leftmost. This becomes the leftmost non-terminal. So this becomes leftmost non-terminal. So here you want to make the replacing here derivation nothing but I am showing this type of symbol. So now I am replacing this symbol with the ID is I want to this becomes no ID plus ID. So here you want to make a substitution. I is becomes ID because I am taking the portion is I becomes ID. So now I become totally for the string is becomes ID plus E. So after that again, I think it is a terminal, or now it becomes non-terminal only. So here your replacement is here it becomes leftmost non-terminal. ID is not a non-terminal; it is a terminal. So now only capital E as only for single non-terminal only itself it is becomes leftmost non-terminal. So you want to replace this, then you are getting the idea is I want to replace this symbol with the second production. Means in the place of E, I am substituting E into E. As per the formula is E becomes E into E. So after that, I think I am trying to getting the format of the as per the input string form. And again, now it becomes leftmost. I am substituting here ID plus ID. With the help of replacement of what is the production is E becomes the ID. And finally, I am going to take ID plus ID into with I. Here also you make the replacement E as ID. So here finally you are getting the ID is ID plus ID into ID. So in this way, I'm trying to make some derivations. This kind of derivation is called as leftmost derivation. Leftmost derivation one I'm observing. Leftmost derivation one. Suppose similarly I'm trying again the say for the same input string another leftmost derivation. I'm assuming that is called as the leftmost derivation two. Leftmost derivation two. So out of them, but I will show with the solving of leftmost derivation two for obtain the same string is called as id plus id into id. So now I have to getting the again the idea is now I'm going to this construct the leftmost derivation. The number is two. Left number is two. So here what is the leftmost derivation two is? I'm starting here again from the same string or we go for you want to solve the id plus id into id. Yeah, I'm trying to get in the same input string but starting from some another different derivation. Previously I started e derives the e plus e, but here I started with a different leftmost derivation now. So I'm starting with here e into e. So here what is I think again your replacement is becomes leftmost variable. Now I'm going to what the e nothing but as per the first production e becomes e plus e. So in this case I want to make a substitution of this e plus e. So here I am getting the e plus e with capital E. Okay. So here mostly I am getting this format only. You have check it and the place is there and asterisk symbols are there. Just only the left thing is e becomes id only. So here where I think sorry it is for the leftmost derivation. The leftmost derivation here leftmost variable. So here this is the leftmost variable. I make the substitution directly for e becomes id with the help of the production is e defines id with e into e. So similarly you are going to substitute here also becomes e implies id, here also e implies id. Finally I got the string format id plus id into id. So I think this leftmost derivation is different leftmost derivation. I am assuming what is the leftmost derivation 2. Okay. So previously I have shown leftmost derivation 1 because of I started the process also different. Previously I started from e implies e plus e, but here you started with e implies e into e. So I am treating as these two are the different leftmost derivations. Means what I am applying here nothing but I am applying the two different leftmost derivations for obtaining the same string. So this becomes the major idea of ambiguous grammar. So in the case of ambiguous grammar, you should remember you are trying for different derivations that may be for different leftmost derivations or different rightmost derivations, whatever that. So once you have got those LMD or RMD, based upon that you are constructed different positives also. So with the help of different positives, you are trying to say that I am obtaining the same input string based on the different derivations. So then you can easily prove. Hence, we have to prove that you are showing the grammar becomes ambiguous grammar only. So this is I think example of ambiguous grammar and as per the definition, as per the concept. And next we have to verify another example is given verify the following grammar is ambiguous grammar or not. Okay. Yes, you can verify the following grammar is ambiguous grammar or not. So I think what is given is here you are taking this assume the production P1, it's the production P2, and I think you are taking this assume the some input string. So means you are trying to defining the P1 and P2, P1 P2, and also for the same string is I think we are assuming it's the input string is so if A1 then so if E1 then if E2 then S1 else S2. This you assume the input string means you are going to prove what is the exact nothing but you are trying to prove different leftmost derivations, two different leftmost derivations, or two different rightmost derivations, or two different positives. Okay, for obtaining the same input string, for the obtaining the same input string. So means attend. I think you are concluding that what you assume the string is this. This is the you assume the string. So when you going to apply the derivations using available these two productions, finally you must show that after completion of the derivation, the final obtained string is this is the string. So for this obtaining of this thing, you must showing the different derivations. So here already I shown the example is the left number derivations. So like similarly you also the some right number derivations also. But left the thing is remaining part is the past is. For this case, I'm going to with the past is idea only. You have to check out what the example is exactly. If E1 then E2 then E2 and again it's I think another if else within the if else this is just like the some nested if fashion only. So as per this nested if fashion, and you're trying to generating I think for applying same string. I think here if we have to compare the if statement is here. Also if is got you got, and next one is the E1. You check it in the past is also E1 is also matched. I think you have to go for then again you have to start another if means in the if I am putting another if just like nested fashion. So finally after going to solve the construction of this different these two different past days, finally I am getting what are the things nothing but 24 two different past days. That means this I am assuming for past 3 1. Okay, this I am taking the another past 3. Means here you check the derivation is we started from what this is some starting variable is called as starting variable is nothing but statement. Okay, so because as per the productions you are checking this I think you are starting this is the starting. So from this you are starting, this becomes the root node. It derives all the things if expression then statement. Okay, I'm taking the same thing if expression then statement. Next, I am trying to here this is a non-terminal. This becomes non-terminal. This becomes non-terminal. You are going to expand this expression only. Becomes the E1. It becomes E1. Uh, then again we have to go to expand. The next time is non-terminal. This is another non-terminal. Two non-terminals here. It's a leftmost non-terminal. It's another leftmost non-terminal. So either finally I am achieving what the string is. I am obtaining the string is if E1, if E2, then S1, else S2. So we have to apply the same, I think same string, okay, using another different pasties, another different pasty 2. Means here I am trying to showing is by the construction of two different pasties, I am obtaining here the same string only, whatever input string is mentioned, the same string is obtained using the two different pasties. So each pasty becomes, I think, derivation of either left mode derivation or right mode derivation. So basically, the pasty idea is you should start it with some root node, and root node that may be expanded as per the idea of either left mode derivation or right mode derivation. So like that, you have to expand until you have to getting the all becomes. I think leaf nodes. Leaf node becomes terminals only. Then you have to stop the process. So this I think from root to the last leaf nodes, you have to imagine try to all leaf nodes. The sequence is left to right. You have to obtain the some string that should be matched with the given input string. So this is the way I am going to construct the pasty. Okay, pasty also some tree kind of representation. So I am going to construct the pasties based upon the either left mode derivations or right mode derivations only. Here I am applying the 24 different pasties for the same string only. Okay, this is the idea. So for proving of this becomes 24 ambiguous grammar. So as per the ambiguous grammar, already we have interacted with the one idea is we have proved already one example is with the 24 left mode derivation 1, left mode derivation 2. Already I have to show some example using two different left mode derivations for obtaining the same string. In a similar way, you are assuming like that two different right mode derivations also sometimes you are talking the same string. That example is covered. So another example is pasties example. So how can you show that using two different pasties? Okay, we obtain the same string. I think for the proving of ambiguous grammar, this is an example itself explain about construction of two different pasties for obtaining the same string. So this referring to the some ambiguous grammar, but already to given some idea is ambiguous grammar. I think it is not good for the compiler construction because of ambiguous nothing but we have tried to reach one particular destination using more than one derivations, talking about more than one different paths from the source state to some destination state, unless we have to increase the complexity by increase the number of states or by increase the number of edges, so that the complexity of the I think the finite automata is increased, the complexity of the complete construction is also increased when you are taking any language grammar that becomes ambiguous grammar only. So you should be careful. The grammar is ambiguous, and then you should convert the grammar that should be in the form of unambiguous grammar only. Then only it is good for the compiler construction. So this example case, the same example case, what is the equivalent unambiguous grammar is. So suppose you are taking the grammar is rather than the previous representation, and you are taking here in this representation, that is nothing but unambiguous grammar case, then it is useful for optimizing the compiler construction. So I think that case you have to recommend that this unambiguous grammar. So I think some of the examples also given, examples of derivations for understanding of leftmost and rightmost derivations for obtaining the same string. Okay, so this is also left for you, and you are going to solve what are the leftmost derivations for understanding of leftmost derivations. For example, I am starting with this 0 is 1. Okay, you want to obtain this string 3 zeros and 3 ones. So many times I am making the substitution one more time is this becomes 0 is 1. Okay, like this. Again, this becomes again using the same production. This becomes 0 3 zeros s 3 ones. So that case we can know that this becomes 3 zeros and 3 ones, means we can easily have getting the idea is 3 zeros and the 3 ones. So this I think for the revising of what of the understanding of leftmost derivations in a similar way, rightmost derivations are I think the same because of only for single non-terminal only. Either you are assuming this for the leftmost derivations or rightmost derivations also. Because of if you have the more than one non-terminals, I think their derivations are different. Okay, their leftmost and rightmost derivations are different, but unfortunately here only for single non-terminal only itself you assume the leftmost non-terminal or also rightmost non-terminal. So that's why I think leftmost LMD and RMD derivations are same for obtaining this string. In a similar way, you can also try for this another example for obtaining of this string, either leftmost and rightmost derivations. After that, you try to construct the past tree also. It is also very easy representation because of this case you should start it like this. Okay, 0 is 1. Again becomes 0 is 1. So again this becomes 0 is 1. So finally becomes null with the help of this one. Okay, finally you have to getting the 0 1. Means you have to see we have mixing of all leaf nodes. So what you getting is finally your obtaining string is 3 zeros. So these I think these are examples illustrating for understanding of the basic idea of LMD and the RMD and also past tree construction. So I think with this we are concluding today's topic is ambiguous grammar. The advantage of ambiguous nothing but we are not recommending always ambiguous. If it is ambiguous, the better thing we convert into unambiguous. Before that, how can you understand the ambiguous grammar? What are the definitions? What are the relevant examples? And all things we have to discuss today. So these topics are referred from these following references. So one is compilers principle and technical tools, and another web link also given. So from these two references, I think we have collected today discussed things, and with this I think we have to conclude today's topic is about ambiguous grammar. Okay, so now I think thank you to everyone.
Like, share and subscribe. Hit the bell icon for more updates.